Okay, so what you have here, the question says, the lift in the world's tallest building takes 64 seconds to reach a height of 828 meters. The maximum mass of the lift and the passengers is 900 kilograms. Calculate the power of the lift. Now you need three equations for this. Power equals energy divided by time. Work done, which is energy, equals force times distance, and weight, which is a force, equals mass times gravity. Okay? Because the question wants the power, but they don't give us energy. They do give us time. Okay? We can get energy by calculating force times distance. We have distance, but we don't have force. We can get the force by timesing the mass by gravity to get the weight. And as you know, weight is a force. Okay, so what we do is we take the mass, which is 900, we times it by 10, because that's gravity on Earth, to give us 9,000 newtons. And we take 9,000 and we multiply that by the distance. That will give us 828 meters. Okay? We multiply it by 828. That would give us the work done. Okay? Work done is 7,452,000 joules, apparently. And then, afterwards, you would take that and you would divide it by the time, which is 64 seconds. And that should give you a power in watts. You'll need to check these values. The next one says a service lift in the building is used to move furniture to apartments in the tower. This lift has a 130 kilowatt motor. If the maximum load for this lift is 2,000 kilograms, how long will it take to reach the top of the building? Once again, we use the same three equations, but this time it's asking us to calculate the time, and we are given the power. Okay, so it means we need to rearrange that top equation. Okay, so first of all, we need to convert kilowatts into watts. So that's multiply that by 1,000, and then follow the same principle. So 2,000 times 10, which is gravity, will give us our force. So that's there, our force, 20,000 newtons. We can plug that into the equation times distance. So it's 20,000 times the distance, which is 828, will give us the work done. And then, once we've got that, we divide the work done by the power. We divide that by so we've got energy. We divide the energy transferred by power in order to get time. Okay, if you put in a formula triangle, energy will be at the top. I don't know if you remember the PET equation. Yeah, so power, energy, time. So covering up what we would try to find, time, and it would give us energy transfer divided by power. So there's our energy divided by power, and it will give you a time in seconds. Okay. The next one is on specific heat capacity. Specific heat capacity is the change in mass. Change in energy is equal to mass times specific heat capacity times change in temperature. So there's your change in mass. So your mass is 30,000 kilograms. You times that by specific heat capacity, which is 4181, and then times that by your change in temperature. And change in temperature, it went from 8 to 15. So that change in temperature is 7 degrees. So 30,000 times 4181 times 7 will give us your answer in joules. Okay, the next one is on a sunny day, the concrete at the side of the pool feels much hotter than the water, even though both have received the same thermal energy from the sun. Explain fully why the concrete is hotter. So maybe you might want to say concrete has a low specific heat capacity, will take less energy to heat up one per 1 degree per kilogram. And you also might want to make a reference to it's less reflective than water, and water will reflect away the more infrared radiation because it's a bit reflective. Water's a bit reflective, isn't it? And then it talks about an oil-powered power station. So what is the useful energy out? And here you want to think about, obviously, I'm sure you can figure out what the point of a power station is, what energy you're trying to create from one, and then what energy will be wasted in this process. If you think about what energy is wasted in a motor. What useful energy store is represented by labeled X? You look this up, you might find it in a PowerPoint of this week or last week's one. Loft insulation, this one will be on the PowerPoint as well. Then there's this equation here. So company sells two types of electric drill A and drill B. What you would do is you will use energy efficiency is equal to useful energy output divided by total energy input times 100. Give us your percentage. So you'll do that for drill A, so 165 divided by 300, because 300 is whatever you put in, times 100. That will give us your energy efficiency. Remember, your energy efficiency will never be above 100%. If you have, then you've done the division wrong way around. Then you would do, for the second one, 520 divided by 1,100. That will give us your energy efficiency. And then you say whether drill A or drill B is the most efficient for transferring useful energy because it has the highest energy efficiency or whatever. These ones you will find the answer. This one you'll find the answer in your PowerPoint. And then this is the last one here. Suggest why the student chose the large power source. So you would say something along the lines of, basically what you can do is you can use a ratio. You can use ratios to actually find out what the most efficient power source is for the number of charges. So looking at the compacts, if you make them all the same weight, we can see which is the most efficient one. So using ratios, let's make them all 600. So if we get from 100 to 600, times that by 6. So you'll need to times the number of charges by 6. So if the compact charger weighed 600 grams, it would give off 6 charges. And then here's the large one. The mass in grams of that one, times that by 3 to get to 600. So you times that number of charges by 3, and that means it will give you 15 charges for every 600 grams. So you can see whoever made the large power source, whatever company made that one, that's the most efficient at transferring energy. So that is one reason why the student would choose that. So it might give you can state it gives you the most charges per 100 grams or 200 grams or 600 grams, whichever you choose. It doesn't matter so long as you turn them all into the same mass before you compare it. And then afterwards, you would also want to mention something to do with the fact that even though the high capacity one gives the most number of charges. It would also be too heavy or too big or something like that. And maybe the compact one charges, you might want more than one charge or something like that along those lines as a second reason. But you've got to make sure you outline those calculations as well. Hope that helps, and I'll see you later. Have a good weekend.